Hi, I'm Becca and welcome back to my channel where we're building a supportive space for adults tackling maths again using clear step-by-step strategies rooted in educational psychology to help you understand, not just memorise. Today we're going to look at division. And this is totally anecdotal, but I found that people seem to dislike subtraction and division more than addition and multiplication. Don't know, maybe it's because it feels like you have to work backwards or you have to be careful with the order. So, for example, if you do 4 times 5, you get the same answer as 5 times 4. But if you do 10 divided by 2, you don't get the same answer as 2 divided by 10. Whatever the reasons, just seems like people are not into it. We use division for so many things. And basically it's about splitting something into equal parts. So that can be things like sharing food between different numbers of people. Budgeting money is a really common one, so splitting costs between friends or dividing out a budget across a number of days. Time management, so splitting time across tasks. Measuring and cooking, another really common one. Packaging and shipping, so dividing things into boxes, working out how many boxes you'll need. And then, of course, the problems that you'll come across if you're studying for a maths qualification. And division is also used in loads of other maths topics, which we will talk about on this channel. So fractions is a huge one, percentages, ratio and averages, they're just some of the areas where division is a really important skill. I'm going to talk through a range of different strategies you can use for division, and I'm going to add as much structure in as I can and kind of try and give some more conceptual understanding where I feel like it will be helpful. So the first thing to think about is that we can use times tables to help us with division. Those kind of relationships between numbers are really important. So if you know one times table fact, you already know 3 other facts. So let's take this bar model on the screen, which shows us 6 lots of 4. So what we could say from this bar model is we could say 6 lots of 4 give us 24. If we know that single fact, we know some other things. So we also know that 4 lots of 6 will also be 24. But we also know that if we have 24 and we divide it into, let's say, 6 boxes, there will be 4 in each box. And that if we want to know how many 4s go into 24, there will be 6 lots of 4. So you kind of know more than you think you do. So if there's a times table fact that you know, it means that you can also use that for division. So that's one thing to bear in mind. So the next thing we're going to look at is a strategy called the bus stop method, which you might remember from school. It's a really good strategy for short division, especially when you're dividing by a single digit number like we have here. So one way we could think of this first question, 612 divided by 4, is how many groups of 4 go into 612? So I could think of a group of 4. If I wanted to make it more visual, I could sort of draw it like this, 1, 2, 3, 4 in a little group. So I'm going to set up my bus stop. So I'm dividing up 612 by 4. And the aim is to see how many groups of 4 I can make. So the first thing I'm going to do is think how many groups of 4 can I make using 6. So I'm going to count 1, 2, 3, 4, 5, 6. I was able to make one group and I've got 2 left over, so I'm going to just carry that onto the 1 there. And now I need to make 21 using my groups of 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I've managed to make here 5 groups and I've got 1 left over, so I'm going to put that there, carry it on to make 12 and repeat 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That made 3 groups exactly. So I can say that 153 groups of 4 go into 612. For the next question, I'm going to use the bus stop method again. So I'm going to set that up. 600, no, I'm doing the wrong question. So let's do that again. 343 divided by 7. Now, the 7 times tables, I think, are a really tricky one. They're one that a lot of people struggle with. And so I would say, because we're going to be using our 7 times tables, let's make a list of them on the side, and then we don't have to keep counting up in 7s. That bit will sort of be out of the way and done for us, just in case we need to sort of count up a few. So whichever way you find easiest, whether you already know a few or you just want to keep adding 7 until you've done all of them. 35 add 7 is 42, add 7 is 49, and then it's 56. 63 and 70. Okay, so I'm now going to repeat the process. So 7s into 3. I can't get any 7s actually. I can't make any groups of 7 if I've only got 3. So I'm going to put a 0. I'm going to carry that 3. I haven't used it, so I'm going to carry it to the 4 to make 34. And this is where my list of times tables is going to come in useful. So how many 7s can I get into 34? So 1, 2, 3, 4. The next one is 35, so that's too many. So I managed to do 4 groups, and that took me to 28. So I now need to think, what have I got left over from 28 up to 34? You could do dots again, so 28, 29, 30, 31, 32, 33, 34. So that's 6 left over. And now I need to do 7s into 63. So we've got, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is why it's useful having that list on the side, because it means that I don't have to keep working out the 7 times tables in my head. So the answer to that one is 49. Now we're going to have a look at halving. Halving is the same thing as dividing by 2, because you're splitting something into 2 equal parts. So I'm going to show you 2 ways to do this. The first way is the bus stop method that we've just tried, and then I'm going to show you another way, which is called partitioning. So the first one, what is half of 526? As soon as I see half of, I know we're talking about dividing by 2. So I'm going to set up my bus stop. 526 divided by 2. You could use your groups of 2, write down your 2 times tables, or if you're confident with your 2 times tables, just go for it. So how many groups of 2 can I make out of 5? I can go 2, 4, so that's 2 groups with 1 left over. How many groups of 2 can I make using 12? So if we count up in 2s, 2, 4, 6, 8, 10, 12, that was 6. And then how many 2s go into 6? 2, 4, 6, that was 3. So that's one method. Another method is to think, okay, we've got this whole number. I'm just going to draw myself a little bar. It's not the neatest, but that's okay. And I want to share that amount between 2 equal parts. So I could think of it as kind of 3 separate numbers, 638. So I'm going to split that up into the place values. I've got 600, 30, and 8. And I'm just going to break each of those down into halves. So half of 600 would have to be 300. Half of 30, that's going to give me 15 and 15, and half of 8, that's going to give me 4. And then what I'm going to do is I'm going to put each of those into the boxes. So 300 in each box, a 15 in each box, and a 4 in each box. And then I'm just going to add them up. So 315, 315, add an extra 4 is going to give me 319. So half of 638, or 638 divided by 2, is 319. So two different ways to go about halving. I really like this second method. I think it's a really good one to practice to build up your confidence with halving bigger numbers. The next thing we're going to look at is dividing by larger numbers, and we're going to use a method which is called the chunking method. And this goes with the concept that division is like repeated subtraction. Basically, you keep taking away the number until you get to 0, until you've used all of the number up. But that would take ages if you had to take away, for example, if you're going to take away 15 and then another 15 and then another 15, that just takes a really long time. So what we can do is we can group them together or do chunks. So for example, I know that one lot of 15 is 15. I can use that fact to work out that 10 lots of 15 would have to be 150. So what I'm going to do is I'm going to take my number, I want to know how many 15s go into 195, and I'm going to take away 150. So 5 take away 0 is 5, 9 take away 5 is 4, 1 take away 1 is 0. So what I've done there is I've taken away 10 lots of 15 and I'm left with 45. Well, that seems like an easier number to manage, really. So let's see how many 15s I can get into 45. So 1 times 15 is 15. Let's just write a little list here. If I do add another 15 onto that, I would get 30. If I add another 15 onto that, I'm going to get 45. So I'm going to take away that 45. That's going to get me to 0, and that was another 3 lots, wasn't it? So altogether, I got 10 lots and then another 3 lots, which means that I managed to do 13 lots of 15. But I didn't have to take away 15 at a time. I did a big chunk and got rid of that in one go. So this is another method for dividing, especially when you've got larger numbers. Let's try this one here. So we've got 598 divided by 23. So we know that one lot of 23 is 23. I'm going to use the same chunk. I'm going to go 10 lots of 23 must be 230. So let's take that away and see what we're left with. So we've got 598 and we're going to take away 10 lots of 23, which is 230. So 8 take away 0 is 8, 9 take away 3 is 6, 5 take away 2 is 3. So I'm going to just put in my brackets here 10 lots, just so I don't forget. I have to write things down so I don't forget. I'm left with 368, and you might have spotted that actually I could do another 10 lots if I wanted to. So I'm going to take away another 230. So 8 take away 0 is 8, 6 take away 3 is 3, 3 take away 2 is 1. Just going to remind myself that was another 10 lots. And now I've been left with 138. Okay, so I know I can't get another 10 lots. So what could I do? I could do a few things here. One thing I could do is I know that if 10 lots of 23 is 230, then 5 lots of 23 is going to be half of that, because 5 lots of something is half of 10 lots of that thing. And half of this would be 115. So that's one way you could do it. Or another way is that you could write yourself a list of the 23 times tables. So we could go 23 add another 23 is 46, add another 23 is going to be 69, add another 23, I'm going to think of it, I'm going to add 20 and then going to add 3, so 69 add 20 is 89, add 3, 90, 91, 92, add another 23 is going to be 115, which is what I got to there, and then another 23 is going to be 138. So I've managed to get to 138. So I'm going to take that away. That's going to give me 0. So I've used all the number up, and I managed to do 1, 2, 3, 4, 5, 6 lots. So I could have used my 5 lots route there, but if that's not something that would make sense to you or that you wouldn't think of, that's fine. You could just make your list of 23s there. So I can now see altogether I did 10 lots, and another 6 lots, which is 26 lots in total. So 598 divided by 23 is 26. Another kind of common question or decision to make when you're dividing is whether to use remainders or decimals. So let's have a look at how this works. So this is when the number doesn't divide in exactly. So we've got 93 divided by 4. So let's set up good old bus stop for this one. 93 divided by 4. So we're going to do groups of 4 into 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that made 2 whole groups with 1 left over. So now I've got 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I managed to get my 3 groups of 4. So 3 there. I've got 1 left over and I've got nowhere to carry it. So what I can say is I've got 1 as a remainder, 1 that doesn't fit into the group. So I could put my answer as 23 remainder 1. Or another way I could do it is if I set up this bus stop again. We know we can get 2 groups of 4 into 9 with 1 left over, 3 groups of 4 into 13. If I've got nowhere to carry that extra 1, what I can do is I can put a decimal point and a 0. So 93.0 is the same as 93. It just means that I can now carry my 1 there. So I'm going to do 4 groups of 4 into 10. So I can get 4, 8. That's 2 groups. Put my decimal point up there, but I've still got 2 left over. So I'm going to need another 0 to carry that 2. And now 4s into 20, let's count in 4s, 4, 8, 12, 16, 20, that's 5 groups exactly. So we can either say that it's 23 remainder 1, or we could say the answer is 23.25. You might notice if you get on well with fractions that if there's 1 left over out of a group of 4, that's the same as a quarter, and a quarter is equal to 0.25. You might have made that connection, but if you didn't, it really doesn't matter. It's just something to think about, or another way to kind of connect those numbers. The next question says share £15 equally between 4 people. So for this one, we're going to use a decimal because we can share that money between people. We don't need to have something left over. So let's put 15 divided by 4. So we've got 4s into 1. We can't make any groups of 4 with 1, so I'm going to put a 0. Carry that 1. 4s into 15. I can get 4, 8, 12. So that's 3. And I've got 3 left over. So I'm going to put myself a decimal point 0 and carry that 3. So now I need to do 4s into 30. So if we count up in 4s, 4, 8, 12, 16, 20, 24, 28, that was 7. 28, I had 30, so I've got 2 left over, so I need another 0. That 2, and then 4s into 20 go 5 times. So that answer is £3.75. It sort of doesn't make sense to have a remainder there because I can divide that amount of money equally between the 4 people. So I used a decimal for that one. So that brings us to the end of this video. We've covered a few strategies for division, including mental and written strategies. We've looked at bus stop division, we've looked at partitioning and chunking for dividing with larger numbers. In the next video, we'll look at how to apply some of these strategies to exam style questions, especially for functional skills and GCSE type questions. So please give the video a thumbs up and subscribe to the channel, and I will see you in the next video. Bye.